Hi, boys and girls. This is Mrs. Atkinson, and today we're going to be talking about place value relationships. But before we do, let's talk about what we've learned so far. I have a number here, 1,248,967. Now that's a pretty big number. We learned so far that each digit has its own place value, depending on where it's located in the number. For example, this 7 is in the ones place. The 6 is in the tens place. The 9 is in the hundreds place, and so forth as we go through the number. The value of each digit is dependent upon the place that it's located in. For example, this 9 here isn't just a 9. Its value is actually 900 because the 9 is located in the hundreds place. Similarly, this 2 is not just a 2. It's actually worth 200,000 because of its location. We also learned that besides writing a number in standard form, we can write it in number name or word form, and that's when you spell out the digits in words. It takes a lot of effort. Your hands might hurt a little bit after you're done, but it's effort well spent when you get to read this big long number. So if I was going to write out this in word form, it would simply be 1 million, comma, make sure the commas go wherever they would normally go in the number in standard form. 248, which is how I would read this, 1,000, comma, 967. You may also notice that it's appropriate to put a little dash when you're talking about like a two-digit number, like 48, 67, 23. Those numbers would have dashes written. Finally, we've talked about expanded form. Expanded form is the ability to write a number using plus signs and zeros. At least that's how I remember it. So if we were going to write our original number up here in expanded form, we would write it out according to its value. So the 1 here has a value of 1 million. That 2 in this number up here had a value of 200,000, and so on and so forth. Today, we're going to be talking about place value relationships. So you might want to grab, I'm going to rip this out, you might want to grab your notebook if you have one, your math notebook, and take some notes if you would like. Feel free to pause this video as often as necessary, and you can also rewatch it as often as you would like. So I have written already a title on my notebook page and a very large number. This number is in the millions. I want you to take a second and try to read this number out loud right now. Did you say 6,229,955? If you did, awesome job, guys. So you might have noticed there's some double digits in this larger number. And I've done that actually on purpose because today I want you to be able to recognize that a digit in one place has 10 times the value of the same digit in the place to its right. Now, that might sound a little confusing, so I'm going to show you what that means. This 5 is in the ones column, and it's worth, well, just 5. But this 5 is in the tens column, and we know that it's not worth just 5. It's actually worth 50. So I could say that the relationship between these two 5s is 10 times. The 5 that's in the tens place is 10 times the 5 that is in the ones place. And that makes sense because 50, right, or 5 times 10 would be 50. And that is what the value of this 5 is. Similarly, we have two 9s that are appearing here in the hundreds and then in the thousands place. These two 9s also have a relationship. The digit, this 9 in the thousands place, is 10 times greater than the 9 that appears in the hundreds place. And that makes sense too, because 9 times 10 would be 90, right? And the difference here is the 10 times greater. Just like that, we could also say that this 9 here in the hundreds place is 1/10 the value of the 9 in the thousands place. Just another way to think about it. Let's continue on. I see 2 2s over here, and I can say that the 2 in the hundred thousands place is 10 times greater than the value of the 2 in the 10,000s place right there. All right, I want to show you something else. But before I do, I want to just talk about an easy way to remember place value relationships. Whenever you have the exact same digit right next to each other, right? They're neighbors, they're right next to each other. The digit to the left is always going to be 10 times bigger than the digit to the right, right? We can see that here with our 5s, we can see it with our 9s, and we can even see it with our 2s. But the key is that the digits have to be exactly the same in order to make that hold true. And the reason why all this works, guys, is because our number system is a base 10 number system. Everything is, with our numbers, everything is based on 10s. Let's take a look at another example. You already know, just because we just learned, that whenever we have 2 of the exact same digits right next to each other, like this 44, 4 and 4, the digit to the left is always going to be 10 times bigger. If we were in the classroom right now, I would have everybody standing up and marching around saying 10 times bigger, 10 times bigger. Just like if it's right next to each other, it's 10 times bigger. I want you to think to yourself, well, what if they're not right next to each other? What is the relationship between these two 4s, the 4 in the ones place and the 4 in the hundreds place? Well, if it's 10 times bigger right next to each other, then you got it. It's 100 times bigger when there's one little guy in between. So this 4 that is in our hundreds place is 100 times greater than the 4 that appears in the ones place. And I bet you're thinking, well, Miss Atkinson, what if we skipped 2 spaces? Right? I'm hopping over these 2 4s. And so now let's compare the relationship between the 4 in the ones place and the 4 in the thousands place. Yes, you got it. It's 1,000 times greater, right? 4 times 1,000 would be 4,000. And 4,000 is 1,000 times greater than a 4, right? Making sense? All right. To sum up, whenever you have the exact same number right next to each other, the digit on the left is always going to be 10 times greater than the digit on the right. If you happen to have the same exact digit, and there's only one little guy in between, right, then we can say it's 100 times bigger. If we have 2 friends in between and the same digit on the outside, it would be 1,000 times greater. Now, the standard in 4th grade is just to learn the 10 times greater. So in our work today in math, you're going to be noticing most of our work is going to end up being 10 times bigger. Let's take a look. Open up to workbook page 11. That's where you should be. Workbook page 11. If you want to rip it out, go ahead. Just keep it in a safe place like a folder. And let's take a look at the solve and share real quick. What is the relationship between the value of the first 5 and the value of the second 5 in this number? 5,500. So if we wanted to, we could actually, I need a thinner marker here. We could actually write it in. They give us a nice place value chart. They separate the little periods for us. I love it. So I have 5,000, 500. So if I want it to write, I'm going to write it a little bit bigger though, 5,500. And they want to know, what is the relationship between these two fives? Well, Mrs. Atkinson just taught us that whenever you have the exact same digit right next to each other, the digit on the left is always 10 times greater than the digit on the right. So we can write that. We can say the 5 in the thousands place is 10 times greater or bigger than the 5 in the hundreds place. All right. So we can use place value to analyze the relationship between the digits in our problems. Give you a second to copy that down. All right, it's always going to be 10 times greater, 10 times greater. All right, let's turn that page, and I want us to take a look for a quick second at this picture. You guys may remember from 3rd grade these base 10 blocks. That really big chunk block, it was like a really big one. That actually was worth 1,000, right? And when you had like a thinner piece, I wish I had them to show you, but I don't have them here, but it looks like this. This was worth 100. If you counted up the little tiny cubes, there would be 100 because there's 10 this way, there's 10 that way, 10 times 10 equals 100. So we can kind of see how what the number 1,000 is related to 100 just here in this picture. If we took 10 of these hundreds blocks and we stacked them right next to each other, it would look like this. It would be equal to 1,000. So when two digits next to each other in a number are the same, and that's the key here, the value of the digit on the left is always 10 times as great as the digit on the right. That's the key understanding. So let's do a little practice. I am now on page 13 in my workbook. Workbook, page 13. And you should be there too. I'm going to skip a little bit right around to number 3. They want us to name the values of the given digits in each number. And then they want us to tell them what is the relationship between these values. So this is going to be, we have a little bit of writing to do in this space, but we got this. All right. So they want to talk about the 7s that are in this number, 7,700. All right, I could talk about that. Well, that 7, I'm just going to draw an arrow, is worth 7,000, right? That's the value of it. And this 7 is worth 700. That's the value of that number. So what is the relationship? I can say that the value of the 7 in the thousands place is, I'm going to shorten here, I'm going to go like that, 10 times the value of the 7 in the hundreds place. Ugh, a lot of writing. You can always pause the video if you need to. So we know that the value of the 7 in the thousands place, is going to be 10 times greater than the 7 that is appearing in the hundreds place. Similarly, in question 4, the 4s in this number, we could say that the 4 in the hundred thousands place, I'm going to try to abbreviate here. hundred thousands place, we'll abbreviate, is 10 times bigger or greater than the 4 in the 10,000s place. And there we have it. So a lot of writing. Pause that video if you need to, but that is what we need to be writing here when we're explaining the relationships. So let's do a few others. They want us to name the values, which is much easier. We don't have as much writing here, of the 2's in 6,228. So our first 2 is worth 200, and that next 2 is worth 20. All right, that's pretty easy. Let's move on. The 5's in 55,714. Well, we have a 50,000, and then we also have a 5,000. How about the 4's in this number? Well, we have a 4,000. That 4 is worth 4,000. And that 4 in the hundreds place is worth 400. Okay, I want you to see if you can finish up doing as many of these as you can, and your teacher will explain what we're going to do next. Have a great day, everyone. Was this not